The question number 3 says a student determined the speed of ultrasound in air using the apparatus shown. So the student added water to the transparent tube. So basically this is the transparent tube where there is water to change the length of S of the air column. So basically if you increase the water, the S of this air column will decrease. Okay, so that is how he will be maintaining or increasing or decreasing the height of the air column. Okay, describe a method to determine a single value of S as accurately as possible using a meter rule. So basically you will have to use a meter rule, and they have asked us how to do it accurately, and the question is a 3 marks question. Now let's solve it in the best possible way. Now to measure this height with a meter rule accurately, let's say this is a meter rule. So when we will be measuring the height with a meter rule, you have to make sure one thing, that is the meter rule is completely vertical or not. Let's say if the meter rule wasn't completely vertical and let's say the meter rule was like this, then the height will be small, right? Or it will be the meter will be giving a greater height than it is actually. So we have to make sure that the metal is completely vertical, and to make sure that the metal is completely vertical, we have to use set squares. So if you use set square right here, it gives an indication whether the meter rule is completely vertical or not. So basically we will have to use a set square to make it as accurate as possible. And the second way we can make it accurate is we can check the zero of the meter rule is level with the surface of the water. Okay, let's say here that I have made a mistake. You guys can see that I have put the meter rule a little above the surface of the water, right? So basically we have to make sure that the meter rule is completely in line with the surface of the water, which is right now, right? So basically this will give us the best possible height of the S, right? So basically we have to make sure the meter rule is in level with the surface of the water. Okay, this is one thing that we have to make sure. And the next thing that we have to make sure is we will have to look at the reading of the meter rule. We have to take the reading of the meter rule from this position. So basically the meter rule is vertical, and we will have to take the reading horizontally, I mean perpendicular to the meter rule, so that we can take the better reading and we can avoid parallax error. So this is how we will be doing. We will be taking the value of S accurately. So basically I've written the answers. Clamp the meter rule in position or ensure the meter rule is vertical using a set square. Check the zero of the meter rule is level with the surface of the water. So basically you will have to keep the zero of the meter rule in surface of the water. Let's say if this is the zero part, this should be in surface of the water. Okay, view the meter rule perpendicularly while taking the reading. As the meter rule is vertical, we have to take the reading horizontally to make sure that the parallax error is reduced and we can take a better reading and as accurately as possible. Now let's move forward to the question number B, which is one of the most difficult question in which students faced a lot of issues. The question says the ultrasonic transducer emitted pulse of ultrasound. Okay, the emitted pulse were reflected at the water surface and then detected when they returned to the ultrasonic transducer. So let's say you have a transducer right here, and from the transducer you are giving, you are actually emitting pulses, and that pulse will go and reach this water. Okay, the pulses will go and reach the water. After reaching the water, they will come back, they will reflect back. Okay, they will basically reflect back to the transducer. They will basically reflect back to the transducer. So basically they are coming back to the transducer. So there is one emitted pulse and there is one reflected pulse as well, which is coming back to the transducer. The student connected. So basically one thing that you guys can see right here is the questions. Okay, let's read the question first. The student connected an oscilloscope to the transducer to determine the time between an emitted pulse and the reflected pulse. So how much time it takes for the pulse to be after emission. After emission, how much time is it? How much time does it take for the pulse to go and then come back again to the transducer? This is what this oscilloscope screen is showing. Okay, the horizontal axis represents the time. So basically this horizontal axis will represent time. The time scale was set to 0.5 milliseconds per division, so it is 0.5 into 10 to the power minus 3 always. Okay, 0.5 milli per second per division, and we know the time is always in seconds, so we have to convert it into seconds. We have to convert the millisecond into second. So basically for every one division it is 0.5 milliseconds, right? 0.5 milliseconds, so 0.5 into 10 to the power minus 3 seconds. Show that for this example the speed of ultrasound in air was this. So basically they're asking for the speed, and they have given us the length of the column as 49.7. so basically length of the air column is this place which it will be covering, right? This is the distance that it will be covering, and as it is going first, hitting the water and then coming back again, so basically he is covering this distance twice, right? So we know the formula of speed. They have access to figure out the speed, right? So speed is equals to distance by time, right? And here the distance will be 2d. Why? Because the pulse will be emitted, it will go and hit the surface of the water, and it will come back. So it is 2d divided by the time. And they have also mentioned that the time between an emitted pulse and reflected pulse, between emitted pulse and reflected pulse, that's why we have taken 2d. Okay, and now let's take out the time. We know every box represents 0.5 milliseconds. Now this was the emitted pulse and this was the reflected pulse. So let's say this was the emitted pulse and this was the reflected pulse. Now let's see how much time was there, or how much boxes are there between these two pulses. This is one box, this is two, this is three, this is four, this is five, and this is six. So basically there are 6 boxes, which means 6 into 0.5 into 10 to the power minus 3 is the time taken for the pulse to go, hit the water, and then come back again. So we know this d can be replaced with the distance that they have given us. The distance will be 49.7 into 10 to the power minus 2, because we have to convert the centimeter into meter, as speed is always calculated in meter per second. So basically our answer will be 331.3 ms minus 1. Hopefully you guys have understood this answer. Now let's move forward to the next part of the question. The next part says a student varied S and determined corresponding values of B. He recorded the following values, determine the mean value. So we know to calculate the mean value, mean of V will be, we have to add all four of the values. And then we will have to divide by the number of values. There are 4 values, and we will get our mean as 340.8. And as we can see, all the data they have given us in 3 significant figures, so we have to keep the answer in 3 significant figure. So our answer should be 341. Always remember that your answer should be in the same significant figure as the data is provided in the question. The next question says determine the percentage uncertainty in the mean value of V. And we know the formula of percentage uncertainty is uncertainty by average measured value. I have written it like this. Don't write like this in your exam day. Write it in the exact way by writing all the words completely. So the percentage uncertainty is equal to uncertainty to the average measured value. And we know uncertainty can be in 2 types. One is half range and the other one is half resolution. As they have given us data, we will be using the half range. Okay, we'll be using the half range. So here we have to figure out the half range. Our biggest value right here is 342 and the smallest value is 335. So our range will be 342 minus 335, and we have to figure out half range. So range divided by 2. This is our half range. Okay, half range will be divided by the average measured value, which is the mean value. So divided by the mean value, which was 341, into 100%. We will have to multiply it with 100. So basically it will give us a value of 1.8%. Okay, we have got our value as 1.8%. This is our percentage uncertainty, and specifically this part was our uncertainty. Okay, this was our uncertainty. Okay, this was our uncertainty. Now let's move forward to this part. The next question says, the student modified the apparatus to determine the speed of sound in water. He determined the speed of sound in water to be 1,444 with 4% uncertainty. This is the value which he determined, which has a percentage uncertainty of this. The accepted value for the speed of sound is this. This is the reference value that they have given us. This is the reference value. Reference value of the speed of sound in water. And this is the value that the student has figured out. So deduce whether the student's value for the speed of sound in water is consistent with the accepted value. This one was the accepted value, right? Your answer should include a calculation. So this was the value that the student figured and which had a 4% of uncertainty. So the student's value was 1,444 and this was a 100% value. Let's say if this is 100% and it can have an uncertainty of 4%, and the reference value is greater, right? The reference value is greater than this 1,444 value. So we'll be having a greater value if there was a 4% uncertainty. So what we'll do is we'll multiply it with 144 into 104%, which will give us a value of 104% means 104 divided by 100. So which will give us a value of 1502. So as this 1502 is smaller, actually greater than the reference value, as this value is greater than the reference value, so we can say yes, the student's statement is correct. We can write, so the student's statement is correct. Don't worry guys, there is exactly one other way to actually solve this question. The other way is to use the percentage difference way. So how we will be using the percentage difference way? The way to use the percentage difference is, this was our value, right? And this was the reference value. The thing we will be doing is, we'll be subtracting the reference value by our value. So reference value minus our value divided by the reference value into 100%. Not actually 100%. You don't need to do it with 100% actually. Okay, yeah, you can actually do the 100%. So basically we will get it 100%. And when we will do 100%, we will get our value as 2.5%. And as this 2.5% is smaller than the uncertainty value, so we can say our value is consistent and it is correct. Okay, we can say our value is consistent and it is correct. So you can either use percentage difference or you can use this method. Okay, either of them is absolutely correct. Now in the next video we will be solving the last question, which is the question number 4 for the most recent May 2024 Physics Unit 3. If you want us to solve more questions for you guys, please comment down below the paper on which you want us to make a video on. And also don't forget to subscribe our YouTube channel, Exam Essentials, and message us at our Facebook page, Exam Essentials, or WhatsApp us at our Exam Essentials WhatsApp number, which is given in the description box, to join our 2 premium courses to ameliorate your preparation for the upcoming session, whether it is in 25, 26, or 2027, because we always launch 2 courses before every exam session. The description and the details of the courses are in the description box. Don't forget to check it. And the solving video of the question number 4 will be in the same playlist. So go through our Physics Unit 3 May 2024 playlist on our YouTube channel, Exam Essentials. Thank you for today. Goodbye.